Hello students, let's continue solving exercise 12.1 in this video. Seventh problem, from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20 meter high buildings are 45 degree and 60 degree respectively. Find the height of the tower. So, in this picture you can see, suppose AB is going to be the height of the building. Okay, on that building one tower is placed, that is BC. Okay, the tower height is unknown. We don't know the height of the tower. Okay, so from a point D on the ground to the base of the tower, it gives a elevation angle of 45 degree, and to the top of the tower it gives a elevation angle of 60 degree. Okay, so let us consider the distance from the foot of the building to the point as x meter and the height of the tower as h meter. Okay, height of the building is 20 meter, but tower we don't know, that is h meter. So we have to find out the height of the tower, that is h. So let's take triangle BAD. Okay, this bottom triangle we are taking BAD. In that, tan 45 equal to AB by DA. Okay, what's the tan formula? It is opposite by adjacent. So AB by DA. So substitute the value which is known, that is 20 meter divided by x meter. So you will get tan 45 is 1. Okay, so 1 is equal to 20 by x. So x is 20 meter. Okay, let's have this as equation 1. Then taking the other triangle, that is CAD. Okay, this full triangle CAD we are taking. In that we have tan 60. Okay, so AC by DA. Then we got tan 60 is root 3. Okay, that is AC is 20 plus h. H is unknown. So let us write 20 plus h divided by x. From 1 you can write you got x is equal to 20 plus h divided by root 3. Okay, so from equation 1 and equation 2, so that means x is 20 from equation 1, x is equal to 20 plus h divided by root 3. Okay, in the second equation. So that we are equating. So now h is unknown. So keep h in one side of equal to and bring all other terms to the other side. So you got 20 root 3 minus 20 you will get. So both are having 20. So take 20 outside the bracket, and inside the bracket you will have root 3 minus 1 meter. So height of the tower is 20 into root 3 minus 1 meter. Eighth problem, a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 meter, and from the same point the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. This problem is very similar to the previous problem where the upper part we had to find out. Here the lower part we have to find out. If you see the diagram, it's very similar to the previous problem. So we have to find out unknown h now. Okay, so let's start. Let's write the given data. Height of pedestal is h meter and height of statue is 1.6 meter. So 0.6 we have elevation. So height of pedestal is equal to, that is AB. Okay, AB is equal to DB minus DA. Okay, total height minus 1.6. If you do, you will get h. So in triangle ABC, we are taking tan 45 equal to AB by BC. Okay, opposite by adjacent. So substitute the values, you will get BC equal to h. Okay, then in triangle DBC, in that tan 60 is equal to DB by BC. So you substitute 1.6 plus h, that is only dB value, no? So full length 1.6 plus h divided by h, that is BC. Okay, BC value in the previous only we found out it to be h. So substitute BC as h. So you will get tan 60 is root 3. So by simplifying you will get like this. Then bring all h to one side of equal to. So you will get like this. So you have to take h outside the bracket. So if you take h as common outside, you will have root 3 minus 1. Okay. So still more, if you simplify, you will get like this. 1.6 divided by root 3 minus 1 is equal to h. So we need to rationalize this. Then only we can get a value where you don't have root in the denominator. So rationalize it. So after rationalizing, you will get 1.6 into root 3 plus 1 divided by 2. Okay, so still more, if you simplify, you can cancel 1.6 and 2. So you will get 1.8 here. So 1.8 into root 3 plus 1. So height of the pedestal is 1.8 into root 3 plus 1 meter. Then ninth problem. The angle of elevation of the top of the building from the foot of the tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. So the point of elevation is from foot of the other building and tower. Okay, it is like that. So from here, if you see, it is angle 30 degree and here it is angle 60 degree. Only the height of the tower is given, that is 50 meter, and we have to find out the height of the building AB. So h. Okay, so write the given data. Height of the tower is 50 meter and building is h meter. So in the triangle ABQ, you are taking tan 30 degree. Okay, so opposite by adjacent, that is AB by BQ equal to 1 by root 3. So tan 30 is 1 by root 3, no? So that is equal to h by BQ. Okay, so BQ is equal to h root 3. So mark it as 1. Then take the other triangle, that is PQB. In that tan 60. Okay, tan 60 you are having the angle of elevation. So opposite by adjacent, PQ by BQ, that is tan 60 is root 3. So PQ is 50 and BQ that we found out in the previous, no? So you have BQ root 3 equal to 50. Okay, so in the previous only we found out BQ as h root 3. So h root 3 into root 3, because already you have root 3 here. So root 3 into root 3 is 3. So 3h equal to 50. H is equal to 50 by 3. That in terms of mixed fraction it is written. So 16 2 by 3 meter, or else in decimal also you can write. So the height of the building is 16 2 by 3 meter. 10th problem. Two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide. From a point between them on the road, the angle of elevation of the top of the poles are 60 degree and 30 degree respectively. Find the height of the poles and the distance of the point from the poles. So these two are buildings. Poles. Okay, poles of equal height. Okay, height is h. And in between the road there is one point E. Okay, so we don't know at what distance it is. So the road width only we know, that is 80 meter. So the point where it is we don't know. So let us take one distance as x. So the other will be 80 minus x. Okay, then angle of elevation is given. So to this pole it is 30 and to this pole it is 60. This is only given data. So write it, A, B and C, D are the poles and E is the point on them. between them. So angle of elevations are taken and distance between the poles is 80 meter. So AB is equal to CD is equal to H meter, because it is given height of the, it is not given, height of the pole is not given, that's why we are taking as H, and CE as X and BE as 80 minus X meter. So now let's take the triangle CDE. Okay, so here angle of elevation is 30, so tan 30 if you are taking opposite by adjacent, so H by X you will get. So what is tan 30? It is 1 by root 3. So you can make X is equal to root 3 H. Now taking the other triangle ABE. Okay, in that tan 60 equal to AB by BE. So what is AB? It is H, and BE is 80 minus X. Okay, so tan 60 is root 3. So now take this 80 minus X to the other side of equal to, so it will be 80 root 3 minus root 3 X. Okay, so H we got. So both the H you equate it. So one is root 3 X equal to 80 root 3 minus H. Okay, so if you do that, simplify, you will get X is equal to 80 root 3 minus H divided by root 3. Then from equation 1 and 2 we get root 3 H equal to 80 root 3 minus H by root 3. So we have to find out H now. So bring all H to one side of equal to. So you will get 4H equal to 80 root 3. So H is equal to, bring this H to the RHS. So it will come in division. So you will get 20 root 3. So substituting H in equation 1. So X value we can find it out. So X is equal to 20 root 3 into root 3. So root 3 will become 3. So 20 into 3 is 60 meter. So the position of the point is at a distance of 60 meter from the pole CD and 20 meter from pole AB. Okay, so that point is 20 meter from the CD pole and 60 meter from CD pole and 20 meter from AB pole. Then 11th problem, a TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. From another point 20 meter away from that point, this point on the line joining this point to the foot of the tower, the angle of elevation of the tower is 30 degree. Find the height of the tower and the width of the canal. So AB is the tower with height, with unknown height. Let us take it as H, and canal, that is CB, that is also not known, we should find out. So this distance only 20 meter that we know. So let's start in the triangle ABD. Okay, this full triangle we are taking the tan 30. So opposite by adjacent, AB by BD equal to, so H by 20 plus X. Okay, so X is, H also unknown, X also unknown. So here 1 by 3 you will get. So next we are going to find out X in terms of H. Okay, so we got one equation. Then with the next triangle ABC, there also tan 60 equal to opposite by adjacent, that is AB by BC. So you will get X in terms of H, that is X is equal to H by root 3. Now equate both 1 and 2. So you will get H root 3 minus 20 equal to H by root 3. So bring H to one side, and if you simplify, you can get H value as 10 root 3. So this H value you substitute in any of the equations. So I am substituting in second equation. So I am getting 10 root 3 by root 3. So root 3 can be cancelled. So I will have 20 meter. So this implies the height of the tower is 10 root 3. That is H. And width of the canal is 10 meter. That is X value. That is 10 meter. That's all for this video. Thank you, children.